NetBSD 11 is here, and it promises to be amazing. Let's install it and test its real performance, starting with the CPU. The results on 1 and 10 threads were brutal. Stay tuned to discover if this version is really the fastest we have tested. We go to the official website and see the recent release, as well as the improvements made and the supported architectures. Among the supported architectures are AMD 64, Spark, RISC, V, ARM, among others. We download the official DVD release version. We boot the installer, downloaded from the official website. The boot time was very fast. Then the main installer starts up. We select the language, for example English, the keyboard layout, and select to install the NetBSD system to the hard drive. It asks us if we want to continue with modifying the disk. We press yes. Then we select the installation disk and GPT table. Now it asks us about the disk geometry. We press yes. Then we select the default partition sizes for the installation process. After pressing yes, the creation of the necessary partitions will begin. We select the BIOS console and the full installation. This complete installation includes the X11 server. We select the source, which is the DVD loaded with the downloaded image. The operating system installation will begin. The release version of NetBSD is 11.0. We wait for it to finish. NetBSD is free, fast, secure, and open-source Unix-based software. It can be used for both servers and embedded systems. When the installation is complete, we press Enter to continue. Then we enter the root system password and its confirmation. In the additional configuration, we go up to the network configuration option. We select the adapter and auto selection. We press Yes for auto configuration. Network setup will start, including obtaining the IP network address using DHCP server. We write the computer name, and if we wish, enter the domain. It asks for confirmation, and if we want to write it to, etc. If you want to add any additional settings, you can do so in the Options menu. In this case, we enable the XDM Display Manager. For proper manager operation, it is necessary to add a user. We enter the username and allow the privileged usage of SU. We select the desired shell. We enter the password for the new user and confirm it. This will be used to log in with XDM. We select Finish Configuration, press Enter to continue, and restart the system to complete the entire installation process. The operating system will boot for the first time. We wait for it to finish and enter XDM. The system boot time is very fast. The system will start with the Display Manager. We enter the username and password to log in. The terminal opens automatically. In the terminal, we run export with pkg path and enter the server cdn.netbsd.org. pkgsrc packages AMD 64 and 1110. Now we run pkg at pkgin, which is the package manager. But it says it didn't find the server. We enter com instead of org. We run export again with pkg path and enter the correct server. We run pkg-add again, but we do not have root permissions. We display the path with echo and then run the su command to enter as root. We enter the password and prompt will change. We run export again with pkg-path and enter the same server we set up for the user. Only this time we run it as root user. We run the command pkg-add pkgin and we see that the package manager was installed correctly with the valid repository. From root, we install with pkgin the Fastfetch packages to see system information and Sysbench for performance evaluation. We also install the Firefox package. In this case, several dependencies are missing, which will be installed automatically. We ran Fastfetch to see system information such as the kernel version, the number of packages installed, and terminal type. We also observed the idle memory consumed and the disk installation size to calculate the average megabytes per package. We run Sysbench CPU run. The CPU test starts with a single thread. It computes prime numbers to measure real performance. At the end, it shows the time, events, and speed obtained from the test. The result obtained in the test was excellent. We run the test using 10 processor threads, allowing us to evaluate parallel performance and simultaneous computing capacity. The evaluation shows the processed events, the time elapsed, and the speed reached during test. The result was very good. Now, we run an execution test to evaluate the system's ability to manage simultaneous tasks and measure system response time. The analysis observes creation, execution, and synchronization, verifying parallel efficiency. The result was average. The test analyzes the use of mutex locks with 10 threads, evaluating how system coordinates shared resources between tasks. The result allows measuring synchronization and efficiency in managing concurrent accesses. The test result was very good. Now we test the memory read evaluation, where the transfer rate values achieved during the execution process are displayed. The data reflects the speed obtained and the performance of the system when accessing memory. The test result was low. In this test, writing data to memory is observed, showing how the system processes and logs info during the execution process. The results show the write speed achieved and the responsiveness of the system memory. The result of the test was low. Then we prepare 1 GB of files in total, generating the necessary data to subsequently evaluate the storage performance. During creation, the sequential write speed achieved by the unit is observed. The result of the test was excellent. We ran a random read and write test, where the storage works with simultaneous access to several different positions. The results show the operations performed and the performance achieved under mixed load. The test result was excellent. The top command is executed to observe the memory consumed by a Firefox window and see resources used during operation. A second tab opens in Firefox, playing a video, then a third and fourth tab open, accessing different website destinations. We can observe the increase in memory used. The memory used per tab has an average consumption between different websites. We have completed the NetBSD tests. We close everything to show the conclusions of the results obtained in the tests made. In conclusion, NetBSD is a Unix-based operating system which has excellent performance according to the tests conducted. Its interface is simple, which is one of its advantages for server installation rather than daily desktop use environment. That's all for this video. If you liked it, subscribe, leave a like, and turn on notifications. See you in the next video.